Hello, hi everybody. Today I'm going to start a new subject, water resource engineering. This is the second subject in your fifth semester. First, I am going to brief you about what you are going to study in water resource engineering, what is the outcome of this course, and also I am going to explain you about the various marks distribution in this particular course, and then we will start unit by unit. There are 6 units. The unit 1 is on introduction to water resource engineering. In each unit we will be having different sections, and each unit and section by section we are going to do the class, right? So first unit is on introduction to water resource engineering. Before starting this particular topic or before starting this particular course, I am going to explain you about various course objective about this particular subject. The objective of this particular course is the student must be able to apply the knowledge of hydraulics in understanding the principles and problems in the area of water resource engineering. Secondly, the student must be able to understand the importance of water conservation and water management for sustainable development. And he must be able to understand the various systems and methods of irrigation, for economic development of the society. And the fourth objective is to apply the technical knowledge in understanding the functions of various hydraulic structures. These are the four course objective of this particular course or water resource engineering. Now coming to course outcome. What are this course outcome? After studying this course, what are the outcomes from this particular course you are going to achieve? Some of the outcomes which you are going to achieve after completing this course are divided into 7 parts. You have 7 course outcome. The first outcome is to illustrate the objectives and quantification of water resource development. The second outcome is to explain the importance and principles of hydrology. Third is inference the various systems and methods of irrigation for economic development of society. Examine the site selection and structural details of water retaining structures. Summarize the details and working principles of distribution, cross drainage and diversion works. Elaborate the protection of groundwater and water resource management. And the seventh objective is engage as lifelong learners and possess knowledge for sustainable engineering solutions in global, economical and environmental issues. Now this entire the course has been divided into 6 units. First unit is on introduction to water resource engineering. Here this introduction to water resource engineering you have for 5 marks, and here the 5 marks question will be asked. Here I have classified into 2 parts. One is A part and B. In section A all 5 marks questions, in section B all 10 marks questions. So introduction to water resource engineering you will be getting 5 marks 1 question and 2 sections. It is divided into 2 sections, and hydrology is another part. It is divided into 8 sections. It comes under unit 2. In hydrology you are going to study about the rainfall, its measurement, runoff, precipitation, infiltration process, and how to estimate the runoff and factors affecting runoff. All these things we are going to study in hydrology. Here in hydrology 8 hours will be covered. Hydrology is covered under 8 sub-units, and 2 questions of 5 marks and 2 questions of 10 marks will be asked. And the third unit is method of irrigation and water requirement of crops. Here in this particular unit you are going to study about various methods of irrigation like surface irrigation, and micro irrigation, subsurface irrigation, surface irrigation, subsurface irrigation, and modern methods of irrigation like micro irrigation. Their advantages, disadvantages, we will be studying. Next, we will be studying on water requirement of crops. In this water requirement of crops, we are going to study on how much quantity of water is required for each crop. We know that different crops require different quantity of water. All crops may not require same quantity of water. Suppose a paddy you take, sugarcane you take, it consumes more quantity of water. Sugarcane is an annual crop. It requires water throughout the year. Whereas you take ragi, it requires less quantity of water. So, how much quantity of water is required for each crops we are going to study? Based on the requirement of water, we are going to supply water to the irrigation fields. That is, quantification of water we are going to study. And also we are going to study quality of water which is required for irrigation purpose, irrigation requirements. Because quality is also very important for water for the plants to grow. So both quality and quantity of water we are going to study in a water requirement of crops. And the fourth unit we are going to study about reservoirs, dams. So different types of water retaining structures, starting from earthen dams to gravity dams, site selection for this gravity dams and earthen dams, and different modes of failures of these dams we are going to study, and forces acting on these retaining structures. We are going to study in detail about this in Unit 4. 10 marks is allotted for this. From Unit 4, we are going to get 2 questions of 5 marks and 2 questions of 10 marks. The 5th unit is on distribution works, cross drainage works, and diversion works. So water which is retained in the irrigation structure like dams and reservoir has to be distributed to the irrigation canals. So how this distribution is done? What type of canals? How the classification of canals has been made? And what are the advantages or disadvantages of canal irrigation? So what is lining of canal? All these things you are going to study under distribution works. Then coming to cross drainage works. Whenever canal meets the drainage, that is say that canal and drainage, when they cross each other, what type of structure to be constructed at that particular place? Sometimes canal may flow over the drainage, or drainage may be above the, drains may be above the canal. We are going to construct certain structures at that particular place like aqueduct, super siphon aqueduct, like that we are going to study in detail about that in Unit 5. The cross drainage works we are going to study there, and diversion works, canal head works, canal head regulators. This diversion works we are going to study in that particular unit. So this is a major unit where you are going to get for 35 marks. 1 question of 5 marks and 3 questions of 10 marks. The last unit is on groundwater engineering and water resource management. So the water will be stored even below the ground also, all of you know that. So what are the factors which governs the availability of groundwater? This we are going to study in this groundwater engineering and water resource management. So how to manage the water. So water has become scarce nowadays. So how to manage it? In some area we will be getting flood, plenty of water will be there, but in some area drought. So how to manage the water when it is under flood condition? How to manage when the water when it is under drought condition? So that water resource management we are going to study in this Unit 6. So from Unit 6 you are going to get for 15 marks, 8 hours is allotted for it. So 1 question of 5 marks and 1 question of 10 marks we will be getting. So this is a overall picture of the water resource engineering which you are going to study, right? Next we will discuss in detail about this water resource engineering. First I will take up Unit 1, that is Introduction to Water Resource Engineering. Today I will be doing the session 1. And my next video I will be covering session 2. So totally we will be having 52 videos on this. 52 sections will be divided into 52 videos. That is unit wise we are classifying it, right? Okay. We will start with the first video on introduction to water resource engineering. So in this video, in this session, I am going to cover the three major topics. One is the introduction part, the second is objective of water resource development. So why water resource development has to be undertaken? What is the need of this water resource development? And the third part is world water resources of India and water resources of Karnataka. So we should have an awareness about the availability of water in world, in India and in Karnataka. So this water resources availability we are going to study in this particular session. Now first let us go for the introduction. What is the need of this particular topic like water resource engineering? What is this concerned with? What is this water resource engineering is concerned with? It is concerned with, first one is utilization of water. So whatever the water which is available, we are going to utilize it. Utilization of water. Why water is utilized? In what way the water is utilized? The water is utilized for irrigation purpose, for water supply, hydroelectric power, even sometimes for navigation also. So what are the utilization of how water is being utilized by us? For irrigation we are utilizing water, for supplying water to industries and cities, and third, that is for domestic. Cities means domestic water supply. Third is the hydroelectric power generation. We construct dam, we retain water in the dam, and this water which is retained is utilized for generation of electricity. Sometimes navigation, to move from one place to another place, we use water as a transport means, like canals, right? Okay. Next is the water resource engineering is also concerned with control of water. In what way the water is controlled? Why the control of water is necessary? We find heavy floods because of continuous rainfall over 2 or 3 days. Say the Ganga river and Brahmaputra river, we are seeing floods every year. Lot of life, we are losing life, and also not only life, lot of irrigated area have been submerged. They have done irrigation throughout the year, but because of the heavy rainfall, flood occurs. And even in Karnataka also, we are seeing in North Karnataka, the Krishna river, every year we are finding a flood in this region, Belgaum region, Gulbarga. This year Gulbarga also we have found a lot of flood. So flood control is also one of the important in water resource engineering. Land drainage. What is this land drainage? Here in land, the land drainage is also important for us. This is you can see the drainage area. This is the waterlogged area. Whenever there is a waterlogged area, this waterlogged area cannot be used for irrigation purpose, because the plants cannot grow in a waterlogged area. Even in waterlogged area, the salinity of soil is also high. Because of this salinity of soil, you will not find the growth of plants. We can't do irrigation in such areas. So we have to drain the water from this particular land. So the land drainage plays a very important role here. This is also one of the thing which we have to concern. This is also one of the concern in water resource engineering. Next is the sewerage system. Whatever the waste water is generated in the city, it has to be properly disposed. And bridge construction, all this comes under control system. Next, third is water quality management or pollution control. is also another concern in water resource engineering. So mainly the water is getting polluted due to various reasons, because of industries, right? Sometimes the agriculture waste also leads to water pollution. Excessive use of fertilizers, sometimes excessive use of fertilizers, these fertilizers will be carried away through runoff water, and it may finally reach our lakes and rivers and drains, etc. So this is also another means of water getting polluted, the industrial waste, the domestic waste from the urban areas. So how to overcome this water pollution? That is pollution control. Water quality management and pollution control is another part of water resource engineering. You can see the control, how we are going to control it by constructing various treatment units. This is one such treatment units where we are going to treat the water, the domestic waste, we are going to treat it. Even in industries also, industrial waste water will be treated, and then the effluent will be left into that is disposed. The effluents will be disposed, which is pure in nature. Next, the development of water resource of a region requires the four headings. One is the conception, the planning, design, construction and operations. So any region, if you want to develop a water resource development, if you want to do for any particular region, the first part is the conception of idea. So we have to make which place is suitable. Suppose if you want to construct a dam or the reservoir, if I want to construct. So first I should have a proper conception, whether it is required or not. So how much quantity of water can be stored in it, whether sufficient quantity of the water is coming inside. So the conception of idea is very important. Second part is the planning. We have to do proper planning of it. Next we have to do the design of the structure, then construction and operations. These are the four stages which comes under the water resource development. And each water resource project, if you want to take up any water resource project, it is an integrated application. It is not done by any one person or one branch. It is an integrated application which involves civil engineers, economists, geologists, chemists, biologists, electrical and mechanical engineers, political scientists, etc. So it is an integrated approach. It is an integrated application of all these branches. Next, coming to objectives of water resource development. What are the objectives of water resource development? First and very important objective is irrigation. So this irrigation is to increase the agriculture production of any particular country. So for this particular irrigation, we require various types of structures like the dams, reservoirs, wells, canals, distribution system, and proper drainage facilities, as I mentioned earlier, farmland, gardening, etc. Next is the hydroelectric power. The objective of hydroelectric power development is generation of electric power for economic development and improvement of any country, any region, any industrial development. We require power. For domestic, we require power. So the power is going to improve the economy of any region, any of country. So the generation of hydroelectric power plays a very important role. So the water resource engineering, the generation of hydroelectric power is another important objective of water resource engineering. Next is the flood control, as I mentioned you earlier. So the flood control can be done by constructing various structures like the dams and reservoirs we are going to construct, and we impound the excess quantity of water is one way of controlling the floods. Flood damage control. How can we reduce the damages due to floods? By constructing structures, river regulation structures on the banks of the river, like dikes. They're going to construct dikes, grayons. We're going to construct on the banks of the rivers, so that we can protect the banks of the rivers by constructing these structures. Next objective is domestic and industrial water supply. This is another important objective of the water resource engineering. Here, mainly in domestic areas, it is very important, water supply is very important. Say in towns and cities where population is densely, where we find dense population, thick population, where population density is very high, whatever the water which is available in the region is not enough for their livelihood. So we need to supply water from faraway place. So water resource engineering plays an important role here. We construct dam, we store water, and this stored water is treated, and this treated water is supplied to the cities. This is one way. Not only for domestic, water is required for industrial use, even commercial use, and also municipal use. And various units which comes under this water supplies are the reservoirs, wells, conduits, they are the pipes, the pumping units, the treatment plants, and distribution system. All this comprises of domestic and industrial water supply. Next is the navigation. So there are the inland navigation facilities are provided for transportation of goods and passengers. So water is also a means for transportation. So the canals constructed purposely for the navigation purpose. So the navigation is also another important objective. So recreational use of water, like boating facilities, swimming pools, and these facilities, if you make, it acts as a recreational use of water. So the recreational use also is one of the important objective of water resource development. I have seen various amusement parks where water is utilized, right? So swimming pools you can say, and amusement parks you can see where water is used for the recreation purpose. So the fish and wildlife protection is also a very important part of water resource engineering. So we are going to construct the fish hatcheries, fish hatchers, and even fish ladders we are going to construct in the reservoirs. And more reservoirs if you start constructing, we can the fish can be cultivated, and wildlife protection also can be carried out by means of this water resource engineering. So this wildlife can be protected. So even in forest areas also, the water resource management is very important, because nowadays you can see the lakes are getting dried in forest. When there is no water in the forest, you can see the migration, the movement of the animals from one place to another place. And even we are observing the death of these animals during summer season. So hence, the water resource management not only is important in the urban areas and also in rural areas, but in forest area also it is important. So by means of this water resource development, we can also protect the wildlife. The drainage control, as I mentioned you earlier, because of the waterlogged areas, when there is a very marshy area or waterlogged areas where that land is not at all utilized for irrigation, we can use this type of drainage facilities. Okay, so drainage pipes we can put, and we can tap the water from the area. And because of this waterlogging, you can see the salinity of the soil. The saline soils, these are the saline soils. Even in saline soils also we can't cultivate. Protecting these saline soils is also a very important part of water resource management. Next is a watershed management. This is a watershed. Watershed is a boundary where the rainwater which is collected will be catched. The water will be catched in this particular boundary, and this forms a watershed. And various objective watershed management. This entire watershed management has to be taken up in an integrated way, integrated management of the watershed. where the soil will be managed. The runoff retardation we are going to do. Whenever we do this runoff retardation by constructing the percolation ponds, so the water is infiltrated inside and it improves the groundwater. And grassland improvement, so the soil erosion, to control the soil erosion we are going to cultivate the grass on the slope, hill slopes. These are the hill slopes where the grass is cultivated. So because of this cultivation of grass, the soil erosion is controlled. This is how the watershed management is practiced. This is also one of the objective of water resource development. Next is the sediment control. You can see the sediments, the soil erosion. Because of this erosion, the soil sediments reaches the reservoirs. These soil sediments in a slopy area will be carried away through runoff water. Finally, it enters into the ponds and finally reservoirs. Because of the inflow of this sediment into these reservoirs, the life of the reservoirs will be reduced. Water storage capacity of the reservoir will be reduced because of inflow of these sediment particles. How to prevent these sediment particles, how to control these sediment particles. So that we are going to, this is also one of the important objective of this water resource development. This can be done by revetment in slopes. Wherever we have slopes, we put a grid, geotextile grid, and over this geotextile grid we put a revetment so that the slope is be protected. The soil erosion in the slope will be reduced. Whenever the soil erosion is reduced, the sediment movement will be controlled. This is the sediment controlling. So these are the grasslands. We are going to planting the grass on the hill slopes, and we are going to grow trees on the hill slopes so that the soil erosion is reduced. And this is another important way of controlling the sediment. These are the percolation ponds. We are going to construct this type of percolation ponds. So by constructing this type of percolation pond, the sediments will be retained here itself, and these sediments can be used for agriculture purpose. And also, if they store this water here, the water impounds into the reservoirs, into the soil, and you can improve the water availability of water in the soil. Moisture control can be improved. The salinity control. Next is pollution abatement. This is also one of the important objective of water resource management. Water conservation is very important. See, this type of the pollution, if it occurs in any region, the precious water will be destroyed. So to prevent this, the water should be treated, and this treated water should be left into the rivers or rivers. And next is the insect control. By providing proper drainage facilities in the waterlogged areas, insect control can be achieved. Artificial precipitation is also one of the important objective of water resource development. Wherever we find the scanty of rainfall, whenever there is no rainfall in this particular region, and cloud seeding is one of the important measures which we can take. Okay, for this is an artificial precipitation. By cloud seeding we can bring rainfall. Okay, so next, so now what we have studied up to the objectives of water resource engineering. Next we will study about world water resources. Water resources of world, water resources of India and water resources of Karnataka. Now world water resources. It is a total volume of water in hydrosphere is estimated to about 1.37 into 10 to the power of 9 kilometer cube, of which 97.5% is locked up in oceans as seawater, and another 2.1% in ice caps and glaciers. Only 97.5%, you can see here, is present in oceans, and 2.1% we find in ice caps and glaciers. Fresh water availability is only 0.6% of the total water resources of the world, and fresh water in lake, tanks, streams constitute to about 0.05% of all the water in the earth. When atmosphere contains 14,000 kilometer cube of water, 0.001% of Earth's water resource. If you see the world water resources, ocean 1.37 into 10 power 6 kilometer cube, polar ice or glaciers 29,000 into 10 power 3 kilometer cube, the groundwater 4067 into 10 power 3 kilometer cube, fresh water in lakes 126 into 10 power 3 kilometer cube, saline lakes 104 into 10 power 3 kilometer cube, soils and subsoil moisture. Even soil moisture, how much quantity of water is available in our soil moisture is 67 into 10 power 3 kilometer cube. In rivers 1.2 into 10 power 3 kilometer cube. At atmospheric water vapor 14 into 10 power 3 kilometer cube. This is the availability of water in the world. This is the world water resources, the fresh water. You can see the salt water and other sources we can see here. Now coming to water resources of India, the Central Water Commission worked out and estimated the utilizable surface water in each river basin, and total utilizable surface flow in all the river basins of the country was estimated as 690 kilometer cube per year. This is the availability of water in the country. So in the river basins of the country, this is utilizable surface flow in all the river basins of the country was estimated to be 690 kilometer cube for 1 year. And these are the different the basins, river basins of India, major river basins of India. This is the Indus River Basin, this is the Ganga River Basin, Brahmaputra River Basin, Mahanadi, Godavari, Krishna, Kaveri. These are the major river basins of India. So coming to River Ganga, it originates at Gangotri Glacier and it falls into Bay of Bengal. So this is east flowing rivers. When it flows into the Bay of Bengal, they are the east flowing rivers. And when it flows into Arabian Sea, they are west flowing rivers. So Brahmaputra, Yangtze Glacier, the Tibet, it moves major cities which is on the banks of this Brahmaputra in our countries, Guwahati and Dibrugarh. And in Ganga, Varanasi, Allahabad, Haridwar and Patna, which is in Bihar. So Indus, it originates in Tibet, that is Kailash range. It flows into Arabian Sea. Like this, Godavari, Trimbakeshwar in Maharashtra, it flows into Bay of Bengal. Some of the important cities are Trimbakeshwar, Nasik, Rajahmundry, Narmada, Amarkantak in Madhya Pradesh. It flows into Arabian Sea. Krishna River near Mahabaleshwar, Maharashtra. So it flows into Bay of Bengal. Yamunotri Glacier. So this Yamuna river is a tributary of river Ganga. So some of the major cities are Delhi, Agra, Mathura, etc. So Mahanadi, the hills of southern Chhattisgarh, Kaveri, Talakaveri, Karnataka. So Bay of Bengal, Tapti, it flows into Arabian Sea. Sutlej, it flows into Indus River, is a tributary of Indus River. Chambal, so Yamuna River, it's a tributary of river Yamuna. Bees, Tungabhadra, Kudli in Karnataka, where it is birthplace. And river Kaveri, Krishna River, it flows into river Krishna River, it's a tributary of Krishna. Sabarmati, it is the Aravalli Hills. Now this is the water resource of India. If you take up Indian water resources, annual precipitation, amount of water precipitation including snowfall is 4,000 kilometer cube is the amount of water as a precipitation which we get. Out of this, evaporation plus groundwater is 2,131, and average annual potential flow into rivers. How much quantity of water flows into rivers is 1,869. And per capita water availability is 1967, this is meter cube, and estimated water resources is 1122, estimated utilizable water resources is 690 kilometer cube, and replenished groundwater is 432 kilometer cube. This is per capita year availability of surface water in India. The per capita means per person how much quantity of water is available. So in India, in 1991 it was 2309 meter cube, and per capita utilizable water availability is 816. So per capita surface water is 2309, but utilizable is 816. In 2001 it is reduced to 1902. The estimated for 2025 and 2050 is 1451. You can see every year, decade by decade, and every 25 years you can see the availability of water is reducing. This is per capita surface water availability is reducing. So we need to conserve more and more quantity of water. Water conservation plays very important role here. So in future population, so availability of water will be less. You can see the per capita utilizable water resources in 1991 it is 816. In 2050 it will be 421. 50% availability is reduced. So we have to go for the modern method of irrigations like the drip irrigation, sprinkler irrigation, micro irrigation. These methods we have to adopt. And water conservation plays a very important role, like rainwater harvesting. All these things we have to adopt. Now coming to water resource of Karnataka. Karnataka state covers 1,91,791 kilometers square of, and Karnataka geographical area is 5.38% of total geographical area of India, and population, you know, in 2011 census it is 6,11,000, 6 crore 11,000, 11 lakh, 6 crore 11 lakh 30,704. And Karnataka accounts to be about 6% of country's surface water resource. About 40% of this is available in east flowing rivers, remaining from west flowing rivers. And this is the river basin map of Karnataka. These are the river basins of Karnataka: Godavari river system, Kaveri river system, Krishna river system, North Pennar, South Pennar, Palar, and west flowing rivers. And these are the references, so from where these slides have been prepared. Thank you.